Hello out there, welcome to this tutorial on trigonometry. In this video, we'll be looking at angles of elevation and depression. First, let's look at angle of elevation. So we look at these to represent a horizontal ground. If you take a pole on the horizontal ground, we call it A, B, and a point P. Then the line joining A and P, we have angle at P to be alpha degrees. Then we conclude that the angle of elevation of the top A of the pole AB, so AB is the pole, from point P, that's this point P on the horizontal ground, is alpha degrees. And it is believed that anything standing on the horizontal ground or standing on any horizontal platform, the angle between that item and the horizontal ground or platform is 90 degrees. Then we look at angle of depression. We also consider the horizontal ground and a pole AB and a point P on the horizontal ground. And for angle of depression, it is from an elevated platform downward, while the angle of elevation is from the down or horizontal platform upward. So like we saw in the explanation of angle of elevation, for angle of depression, it must be up looking down, and elevation, it must be down looking up. So we go ahead and create the normal. Then we call this horizontal platform from A to N as the normal. Then we now have line joining A and P. The angle from ANP, we call it a beta degrees, is angle of depression. So we say the angle of depression of the point P on the horizontal ground from the top A of the pole, from this top A on the pole, is beta degrees. Please be informed that angle of depression is outside the triangle ABP, not inside here, please. And with this diagram, it is believed AN is parallel to BP, so that this angle here is equal to angle APB. We'll be looking at that while we solve some problems. So we go to problem 1. Problem 1, from a point B on the level ground, the angle of elevation of the top of a building 12 meters high is 73 degrees. How far is B from the bottom of the building? Give your answer to the nearest 0.1 meters. That is going to be 1 decimal place. So the first thing is to create our horizontal ground, and a building is on this horizontal ground. This is our building. Call it the top as T and the bottom as A. There is a point on the horizontal ground, so we take the point here as B. The angle of elevation of the top of this building is 73 degrees, so we have the angle to be 73. Then we now join the line T and B, and we said the angle TA makes with AB is 90 degrees, and TA, which is the building, is 12 meters. Then how far is B from the bottom of, that is, we are looking for AB, we name it X. So from here, we know an angle, we know the opposite, we know the adjacent, so we are going to apply the trigonometric ratios of angle, popularly known as SOHCAHTOA. So SOH, that is sine of an angle, is opposite over hypotenuse, while CAH, that is CAH, cosine of an angle, is equal to adjacent over hypotenuse, and TOA is tangent of an angle which is opposite over adjacent. So in this case now we have to examine the ratio that is connecting this opposite and adjacent. Opposite adjacent, that is tangent. So we say tan 73 degrees is equal to opposite. This is equal to opposite, that is 12 over adjacent, that is over x. So we have tan 73 degrees is equal to 12 over x. Now we need to look for the tangent of angle 73 degrees, either from our calculator or from mathematical table. You have it as 3.271, which is still equal to 12 over x. Now we make x the subject of the formula. If we cross multiply, we have 3.271x, then equal to 12. Then we divide both sides by 3.271 so that x becomes 12 over 3.271. Either using our calculator, we have it as 3.667 meters, and to the nearest 0.1 meters, that's to the nearest one decimal place, this is 0.6. Then we check this, since it is greater than 5, so we make it 1, it becomes 3.7 meters. Therefore, B is 3.7 meters from the bottom of the building. So from here, we are done with problem 1. We go straight to problem 2. For problem 2, from the top of a flagpole 18 meters above the ground, the angle of depression of the bottom of a building is 30 degrees. How far apart are the pole and the building? Give your answer correct to 3 significant figures. We said we create a horizontal ground. There is a pole and a building. So we have the pole here, which is 18 meters above the ground. Then we have the building. We are not given the height of the building. Then the angle of depression from the top of the flagpole. From the top of this pole, the angle of depression of the bottom of the building. So this is, we need to create the normal. The angle of depression is set to be 30 degrees, joining that top to the bottom of the building. This angle here is 30 degrees, and this angle here is 90 degrees. Therefore, this is also 30 degrees. So having gotten that one as 30 degrees, we say how far apart are the pole and the building. Take the distance between the building and the pole to be x meters. But now look at which of the ratios will be applicable in this problem. This is opposite, 18 is opposite, this is adjacent. So we are connecting opposite and adjacent, that is tangent. So we have it as 1030 degrees is equal to opposite, that's 18 over x. Now if we make x the subject of the formula, we now have x to be 18 over tan 30 degrees. So we look for what tan 30 degrees is. So we check our table or press our calculator. We have it at 0.5774. Simplifying this, we have x to be equal to 31.17 meters, and since we are to give our answer correct to 3 significant figures, 1, 2, 3, the first 3 significant figures is 31.1. we consider this, since it is greater than 5, we make it 1, so it becomes 31.2 meters. Therefore, the pole and the building are 31.2 meters apart. And that is the end of solution to problem 2. So we go to problem 3. For problem 3, The angle of depression of a point on the horizontal ground from the top of a tree is 58 degrees. If the point is 10 meters away from the bottom of the tree, calculate the height of the tree to the nearest meters. Again, we create the horizontal ground. See, the tree is this, and the top of the tree and the bottom is A, and the point on the horizontal ground is B. The angle of depression of a point on the horizontal ground from the top of the tree, from the top of this tree, we have to create the normal and join TB, and the angle of depression there, the angle of depression is outside with the normal is 58 degrees. So that is the diagrammatical representation of this information. If the point is 10 meters away from the bottom of the tree, so this is 10 meters, we said this angle is 90 degrees. Calculate the height of the tree. We are calculating TA, make it X, and now this angle here is 58 degrees. So we still have opposite and adjacent, so we are using tangent, so that tan 58 degrees is equal to opposite, that is X over adjacent, that's over 10. Then tan 58 degrees is 1.6006, and this is equal to X over 10. So cross multiplying, we have X is equal to 10.003 meters. If you multiply this by 10, we move this point by one step, which gives 16.003 meters, and to the nearest meters is going to be 16 meters. And that's the end of solution to problem 3. We go to problem 4. For problem 4, a boy stands 20 meters away from a telecommunication mast. His angle of elevation of the top of the mast is 60 degrees. If his eyes level is 75 centimeters above the ground level, calculate the height of the mast. This is somehow technical, so we still create our horizontal ground, and the telecommunication mast is this, and this is the boy standing. That's 20 meters away, and we create the normal for the boy. If he's looking normally, this is his line of sight. His angle of elevation of the top of the mast, so the angle of the elevation is 60 degrees. His line of sight is this, and the guy's eyes level is 75 centimeters. Converting it to meters, we have it as 0.75 meters. We label the point A, B, C, D, and E. Now we are to calculate the height of the mast. The height of the mast is AC, and since we have already gotten AB, we need to calculate BC, so we call it X, so that from triangle BCD, we know that BD is 20 meters, so that the ratio here again is tangent, so we have opposites and adjacent. So we have 1060 degrees is equal to opposite X over 20, as opposite over adjacent there. So tan 60 degrees is 1.732 is equal to X over 20, so that X will be equal to 20 times 1.732, which gives 34.64. And to calculate the height of the mast now, We said it is 34.64 plus 0.75, that is BC plus AB, and that gives 35.39 meters. We are not given any degree of accuracy here, so we leave our answer as 35.39 meters. And that's the end of solution to problem 4. We go to problem 5. For problem 5, an aircraft is at a height of 200 meters above the ground. An angle of elevation of the aircraft from an observer 1.8 meters tall on the horizontal ground is 53 degrees. How far is the aircraft from the observer? If you have the aircraft here and it is 200 meters above the horizontal ground, AB 200 meters above the horizontal ground, and the man is at this point C, which is 1.8 meters tall, and the normal we have to create it. The angle of sight here, we can call it at this point, which is angle of elevation of the aircraft from the observer, is 53 degrees. So from the observer here, we have angle 53 degrees. His line of sight to the plane is this. So remember, this is 90 degrees, which makes this one also 90 degrees. We have to calculate how far the aircraft is from the observer. So we are calculating AQ, we call it Y. And remember, BP is 1.8 meters. So that AP now will be 200 minus 1.8. And that will give us 198.2. So AP is 198.2 meters. To calculate the value of Y, which is the distance of the aircraft from the observer, we consider triangle APQ. So we say from triangle APQ, the opposite here is 198.2. We have to calculate the hypotenuse now. So what ratio connects the opposite and hypotenuse? That is sine. So we look at sine 53 degrees, which is equal to opposite 198.2 over y, that's over the hypotenuse. So sine 53 degrees is 0.7986 is equal to 198.2 over y. If you make y the subject of this relation, you have y to be equal to 198.2 over 0.7986. So pressing our calculator, we have 248.18. Now we have gotten the value of y, and we said it represents the distance between the aircraft and the observer. So the distance between the observer and the aircraft is 248.18 meters. And that's the end of solution to problem 5. We go to problem 6. For problem 6, 2 points A and B on the same horizontal ground are on the same side of an electric pole. From the points, the angles of elevation of the top of the pole are respectively 48 degrees and 62 degrees. If A and B are 8 meters apart, calculate correct to two significant figures the height of the pole. We get the horizontal ground. There are 2 points A and B on the same side of an electric pole. So we have the electric pole here. Now from the 2 points, the angles of elevation are 48 degrees and 62 degrees. It should be understood here that the larger angle is closer to the pole than the smaller angle, because you need to raise your head very high if you are close to the pole to be able to see the top of the pole. And if you are far away from the pole, you just need to turn your head a bit, which makes smaller angle. So what we do here, 62 degrees will be here. So the angle of elevation at that point is 62 degrees to the top of the pole, and this one will be 48 degrees up to the top of the pole. Now we know that this is A and this is B respectively. A goes with 48 and B goes with 62. So we have the pole to be C and D. This is 8 centimeters and the height is represented as H. CB is X and this is 90 degrees. Now this is complicated here. What we do is we have two right angle triangles here. So what we do is we pick it one after the other and see how to resolve, because we have two unknowns here. We have two unknowns. We need to find X and H. Now let's look at from triangle BCD. So from triangle BCD, this is opposite, this is adjacent. We are using tangent, so tan 62 degrees is equal to opposite H over X. That is the adjacent. Now if you make H the subject of the relation, that is going to be H is X tan 62 degrees, and finding the value of tan 62 degrees. Tan 62 degrees is 1.881 multiplied by X. We have 1.881X. We call this one equation 1 because we have two unknowns here. Then we now consider the triangle ACD. From triangle ACD, the given angle is 48 degrees and the opposite is H, and the adjacent is 8 plus X. So we now say tan 48 degrees is H over X plus 8, because this is X plus 8. So from here we make H the subject of the relation, which is X plus 8 tan 48 degrees. Tan 48 degrees is 1.111. So multiplying by this, we have 1.11x. So 1.111 multiplied by 8 gives 8.888, and this is equation 2. Now from 1 and 2, since H is 1.111x plus 8.888, and here in equation 1 H is also 1.881x, so we equate them so that 1.881x is equal to 1.11x plus 8.888. Bringing this to this side, 1.881 minus 1.111x is equal to 8.888. This is giving us 0.77x is equal to 8.888, and dividing both sides by 0.77, x will be equal to 11.54. And now we're interested in the height, which is H. So to get our height now, we just substitute x is equal to 11.54 in equation 1, so that we now have H to be 1.881 times 11.54, which gives 21.71. And to three significant figures, we have it as 21.7 meters. And that is the end of solution to problem 6. We go to problem 7. For problem 7, from the top of a mast 150 meters above the ground level, an engineer sighted two spots, one in the east and the other one in the west. If their angles of depression are respectively 30 degrees and 60 degrees, how far apart are the two spots? So we look at it at the horizontal ground, and the mast, which is 150 meters above the ground level. An engineer sighted two spots, one in the east, so one spot here and the other spot here, and the angle of depression from the top here. So we create the normal from here. This is the normal from the top of the mast. So the angle of depression of the one in the east is 30 degrees. So the angle here is 30 degrees. Then we now join it, and the other one is 60 degrees. We join it. So we can name the point A and B, the top here to be T and the bottom to be B. This is 30 degrees and this is 60 degrees. This is AP is A and PB is B. So remember, this angle is 90 degrees. The pole is angle 90 degrees to the horizontal. And now we are going to calculate A, calculate B. Adding them together will give us the distance between the two spots. So let's start with A. So from triangle ATP, so what we have there is opposite and adjacent. That's 30 degrees. Opposite 150 over adjacent, that's A. Now 30 degrees is 0.5774, which is equal to 150 over A. Making A the subject of the relation, we have A equal to 150 over 0.5774, which gives 259.81. Now we go ahead to calculate B, so that from triangle BTP, so we are still using the opposite and adjacent. So we have tan 60 degrees is equal to opposite 150 over B, and that B is the adjacent. Tan 60 degrees is 1.732 equal to 150 over B. If you make B the subject of the relation, B will be 150 over 1.732, which gives 86.61. And now the distance between the two spots is 259.81 plus 86.61, and that will give us 346.42 meters. And since we are not giving any degree of accuracy, we leave the distance between the two spots as 346.42. And that's the end of solution to this problem, and this is the end of this tutorial. Thank you for watching. Like and share this video. Remember to subscribe to our YouTube channel. Check the description section of this video on our YouTube channel to get links to our previous videos and other videos on this topic. Until we come your way again, goodbye.